All right, welcome back to our Department of Energy webinar series on essential topics that are shaping the future of the built environment. You know, we are in the midst of Be Kind to Humankind Week, and there aren't too many people more kind than our guest today. Jim Meyers is back with us talking about the 2021 IECC and how it gets us closer to a net zero built environment than we've ever been before. We're also going to talk about expectations for future code cycles and how those evolving codes will impact design, construction, and product specification. Now, you probably know Jim Meyers by now, but in case you don't, he is the director of the Buildings Efficiency Program for the Southwest Energy Efficiency Project, or SWEEP. In that role, Jim works on increasing energy efficiency in buildings, and he loves it. He's responsible for leading the buildings programs, including the adoption of newer energy codes and standards, going beyond code with green building programs, studies to verify energy savings from both programs and codes, and opportunities for electrifying buildings. Now, at one point in Jim's career, he served as technical director of a home energy rating provider, where he provided rater training, quality assurance, and program direction. He has delivered building efficiency trainings across numerous building industries. Now, currently, Jim was an active participant in the International Code Council Committee, specifically the 2021 Residential IECC Committee. So that's the very code we're going to be talking about today. And we have a number of sponsors for this webinar series. I'm going to start off by mentioning Trane by Trane Technologies, a global climate innovator. They create comfortable, energy-efficient indoor environments for commercial and residential applications. Trane Solutions optimize indoor environments with a broad portfolio of energy efficiency heating, ventilating, and air conditioning systems, building and contracting services, parts support, and advanced control. For more information, please visit www.trane.com or www.tranetechnologies.com. Another sponsor is Goodman Manufacturing. A member of Daikin Group, Goodman is the largest manufacturer of heating, ventilation, and air conditioning products for residential and commercial use. As the North American leader in HVAC, they are focused on design, engineering, and manufacturing of sustainable products that have helped millions of owners achieve reliable, high quality, and affordable indoor comfort. Providing additional support for today's webinar are DOE, Team Zero, and EBA. Now, during the course of today's presentation, you can submit questions for our guest like you always can. Simply use the questions box on the right side of your screen. I'll review those questions and pose them to Jim during the Q&A time that we've set aside after his presentation. Hey, Jim, good to hear your voice again, sir.
Thank you so much, Mike. I appreciate it. Welcome, everyone, about a code update, moving towards net zero. I enjoy this topic because I believe the energy code is moving that way. It's taken a little longer than some would like, but it is moving that way, and we'll see where it's improved, the changes, and we'll also talk about, as Mike said, some of what's happening or what is anticipated to happen in future codes. So I'll go quickly. Let's see, there I am. And there's SWEEP. Well, he pretty much said what we do, and we work in 6 Southwest states. But our focus, my computer is moving a little slow, so I apologize. Come on, computer. Okay. Okay, so we are going to look at, I have these 11 items here that we're going to look at that are focus areas to get a building to zero, to get a residential. We're talking residential today, to get it to zero. Doesn't necessarily line up with Passive House or the Zero Energy Ready Home program, but it's very close there. But these are the areas that need to focus on to help get a home to zero. So performance modeling, are we moving and using software to model to look at opportunities versus just a prescriptive built home? And we'll talk about that with the code and all of this. So I'll mention that as we move along. Okay, performance modeling is the first area we're going to talk about. And The energy code has two pathways for performance modeling. It has the performance path and it has the ERI path. I think many of you are aware that the ERI path came in a couple code cycles ago, and it came in with relatively low numbers. The numbers were raised as there was, for the last code, as there was thoughts on and concerns about construction to those levels. And then this is what is proposed for the 2021. We believe it's going to be there. All the online governmental voting members supported these numbers. Takes it down into the, you can see, mid 50 to low 50 level. The other thing that the code does is previously it had a backstop that you had to use when you use these performance paths, and it referenced a specific energy code. So you had to meet that, and I'll just say R instead of the U. So you had to meet that R30 or 38 or whatever it may be. And in this case, it's moving to the UA, and so there's more flexibility, more benefits for the home builder and the trades, but also need to take into consideration the importance of energy efficiency. Renewables are great, and renewables are the only way we're going to get to zero, but energy efficiency needs to be a major part of this at this point, not yet a zero code, to get to these scores levels. And so if you think of ERI, those that are not familiar with ERI, think of the HERS, the ResNet HERS program, and they both use the same standard. So if you think of a vehicle, one vehicle gets 50 miles per gallon, and a different vehicle gets 50 miles per gallon, it's still 50 miles per gallon. So the score is still the same. The ERI has different requirements than the HERS, additional requirements that are within the energy code. So the Department of Energy, their Zero Energy Ready Home program, states that to get to the HERS, excuse me, to get to Zero Energy Ready, to bring that home to zero, you really need to be in the low to mid 50s. So as you can see in the slide, that the code is pretty much there at that level. Is it going to get you all the way to zero? It depends on the house and the orientation and all those other pieces that come into the play in constructing a building. So the next slide here is the code is also, and other codes are also doing at the state and local level, they're adding additional efficiency. So you're going to follow the base code, and then here's some other requirements, and you get to choose which other requirements you need to use to meet the code, but this also drives you to that zero. So in this case, and there's a few slides here I'll show. So you've got increasing your envelope, improving that, so you're 5% better. Your equipment efficiency, this is where you don't have to worry about the NACA standards that are out there. And so you can go above the minimum efficiency and call it out in the code because it's optional. And so they're for heating equipment and water heat. So then also your duct systems, you get, if all your duct systems are within the thermal envelope in conditioned space. And then another option here is with tight homes, and we'll be talking about that. That's the next item we'll be talking about. So you go below 3 ACH, the codes are recognizing you need to do something about mechanical ventilation, the air quality within that structure. From the energy code, if you're doing the performance modeling, and that was the item 1, we have the 2 performance options, the computer simulation, it's called, referred to as a performance path, and then there's the ERI path. And so the ERI looks at a 5% less number-based, and the performance path looks at 5% lower in annual energy cost as compared to the standard reference design. All of these things can drive down to zero. So further codes, future codes, you could take that ERI and take it to 10%. You could take it to 15. A municipality could drive those scores down, the ERI scores through that percent or through the performance path. But this is now flexibility into the code where states and municipalities can take a model code and move it to zero quicker than might be happening at the national level. So here is that same slide I was showing earlier about the scores, but now if you've followed the optional packages I was just talking about, now you're at the high 40s and low 50s. So those are definitely in the range of what the Zero Energy Ready Home program has referenced within their documentation. Next up is number 2, tight building enclosure. You need a tight building. I think we all know that. And so the codes are recognizing that, moving that way. We're not to the level that you'd see in a passive house, but the buildings are getting tighter and the codes are moving to support those tighter building enclosures. And there are some exceptions with multifamily, as those are a little more of a challenge, constructing to a much lower air infiltration rate. So we have in the code a table. Think of it as a checklist. It's not a checklist. Zero Energy Ready Homes has a checklist. You've got Energy Star New Homes has a checklist. The code doesn't have a checklist, but many use this. Builders, raters, others use this as a checklist and look at the air barrier requirements and insulation requirements as best building practices to be included into the construction practices for the trades. And so what's happening in the code today, there's improvements. This is just one example, improving the descriptive information in the air barrier criteria or the insulation criteria so that buildings and trades can be constructed to the energy code requirements and basically meet manufacturer instructions. So the tight building enclosure, this is where I mentioned just a minute or two ago that multifamily has been a challenge with meeting the tightness levels within the building codes. And so next energy code, and we've been seeing it happen at the state and local level where updates to the code or amendments to the code have occurred where they're including the ability to look at dwellings, multiple dwellings, attached dwellings. And so looking at dwellings, and so then that becomes a challenge with the ACH, the air change per hour, and that, well, the test is the same, but to get to the ACH, you'd have to guard, you'd do guarded, you'd have to know what the pressure is on both sides of the buildings and to do an accurate ACH. And so what some communities have been doing, they've been including an alternate opportunity or option for testing here. And so it's looking at the enclosure area. What is the ceiling, walls, and floor area? And coming up with the CFM per square foot. And this applies to, let me advance the slide. So this applies to attached units. So you've got multifamily, could be a townhomes. And then the other key is it supports smaller detached homes. That's an area that the code has seen some challenges with tightness requirements because the ACH is volume-based. And so you have a smaller home, just like you would have a smaller attached unit, apartment, condo, or something like that, and being able to get the ACH down because the volume is smaller. So the codes accept this. Now, are those equivalent? Is that 0.30 CFM per square foot equivalent to the ACH? Not exactly, or it's not equal, and it's not necessarily equivalent, but it's close. And the codes, I believe the codes will continue to improve and reduce that as the industry comes together and finds ways to build specially attached units that are tighter than what we've seen constructed over the years. And that's going to be new techniques and practices that will be needed. So we're still looking at some multifamily testing. The code says you can do the whole building or you can do individual units, and that's why there's a dwelling unit requirement in there. Testing is mandatory across all of the building types for residential. So the next one, number 3, is super insulation. And so you might think, what is super insulation? Well, it's your perspective. And again, you would see different levels in a passive home than you would see in a code-built home or even a zero energy ready home. But the code is recognizing the importance of having that a good level of insulation. So we're seeing levels now in the 2021, and we're seeing levels at local municipalities that are moving their codes and their municipalities to the goal of hitting 0 in the 2030, 2035 range to these kind of levels of insulation. So much more insulation in the attic. The walls are increasing in efficiency, and slab insulation is moving down into lower climate zones. Some areas of climate zone 3 are colder than other areas of climate zone 3. And so slab insulation will most likely be more accepted in some of those communities than others. But I wanted to point out to you that the code, if you look at climate zone 6, wood frame wall, you'll see the first number there is a 30 or. This is prescriptive, because there was a lot of discussion around prescriptive, and I'm showing you this prescriptive, even though getting to 0, you really need to performance model it. But there has been that discussion point of what does a wall look like if it's only cavity insulation. So 30 was a number that came through the last code cycle, or code, the code cycle, the code change development cycle. And the code, let me mention at this point, the 2021 IECC code is not yet approved. It will be approved in a few weeks. There are a few appeals that are happening at this time, IRC and IECC, over the next few weeks. And then the code will be finalized by the IECC mid-September, mid to late September. So, but 30, that's only prescriptive, but it gives you an idea. What does a house look like prescriptively? And then when you go through the modeling. But insulation needs to improve to get to 0. Windows and doors, the energy code is moving that way. And so windows are improving, the U factors are continuing to go down, solar heat gain is coming into colder climates. And I like to pull up this picture that you see right now. It is a picture of an NFRC label. I took this in 2012-2013 timeframe in a production builder in Colorado, and you can see the U factor is 0.28, and that was going into production homes, just a standard production home, 7, 8 years ago. So we know homes can be built with very energy efficient windows. The code is moving those scores down, and so I eventually plan to see, I am planning to see the scores go down into the 20s. Not that they're ever going to get to the level of a passive house. Let me go to the next slide. There we go. So some of the other things for flexibility and the performance modeling is area weighted averaging max values. Those have changed. Those are better to get the building down to 0. Flexibility, U factors have gone up because the ERI, the energy code has some backstops to maintain efficiency in the building. And the solar heat gain has improved. So there's that, again, that flexibility in the modeling. So right here, we've got the Energy Star new windows criteria, and you can see that there we're pretty much there with the code with Energy Star new windows. Not so much in the colder climate, but we are at 0.30, not yet below that level, but we anticipate those will be coming in future code changes and future code cycles. So ventilation, that's number 5. I'm checking my time, Mike, to see how we're doing. Okay.
Oh, you're doing just fine, Jim. No problems at all.
Okay, great. So we've got a tight building enclosure. We talked about that. Super insulation, more insulation, good windows and doors. And now we need to have a well-ventilated building. That's important. We just can't build it very tight and then not ventilate it. So ventilation continues to come into the code, improvements into the code, and so mechanical ventilation, there we go. Okay, so the mechanical ventilation for the fans, what's happening here is it's aligning with Energy Star. So it's improving the amount of energy consumed per watt for the cubic feet per minute of air that's moved. So it's improving that. Kind of hard to go beyond that, the Energy Star, unless there's another standard out there to reference to. So as Energy Star improves the efficacy of fan efficiency, then I believe the code will continue to move in that same path because those products are becoming more and more well accepted and used by industry. So mechanical ventilation, efficiency in those systems. The other piece about mechanical efficiency is a whole house. So in this case, this is the first step. This is what I see as the first step. And only climate zones 7 and 8, where this applies. So ERV or HRVs are required in those colder climate zones. Will ERV and HRV come down into the warmer climate zones, still cold, 6, 5, 4, and so forth? I believe they will be coming in, especially as the buildings get tighter. And in the earlier slide, I had showed that one of the efficiency options, so you're going to build a very energy efficient building to the code. And then, oh, by the way, you also have to do these additional efficiency options. It had an option in there, if you built it very tight and you went below 3 ACH, then you also had to use an ERV or HRV at that point. And so that would be applied to any, but that was an optional path. In this case, if you're building in climate zone 7 and 8, and well, if you're building there, you have this ERV or HRV required because the air infiltration rates are not tighter, they're not less requirements at those colder climates. So ERVs and HRVs are there. They must be balanced. There's some sensible heat recovery efficiency requirements. And then the other thing, it must be tested. So the ventilation system needs to be tested. So there's already testing going on in the building of, well, and that's a future slide coming up. But it's in addition to the other diagnostic testing that is part of the code. So we're about halfway through these steps. to get to a zero energy building. In the code, again, I'm showing where in the code how it lines up to get a house to zero energy. So heating and cooling, that is the piece that that has some challenges from the code level, because there's something called the National Appliance Energy Conservation Act, NACA. I mentioned that earlier. And that Conservation Act says that there has to be a certain level of efficiency for equipment. That's interpreted by some that that's the maximum you can require within the code. And so even though we know those appliance standards are relatively old, last is 1987, and so the equipment is old. Now, NACA's been updated. The cooling side, air conditioning, those standards have gone up and in efficiency. So you're seeing a minimum of SEER 13. And so requiring a system beyond those NACA standards becomes a challenge in the code. And so they need to be options and optional, but not a mandatory requirement today in the codes. If you're following code, if you're building to a program, that is something different, and you're not tied into NACA. So heating and cooling, duct testing. The code has had this for quite a while. The industry is on board with this, is my take. Maybe not so much in the rural areas, and that's more because of there's just not the trades in some of the rural areas. But it's happening. There are mechanical contractors, HVAC contractors that are going into that market too, to know what they're installing, to understand the leakage rates of their duct systems. So I anticipate seeing more and more of this continuing in construction, but it's in the code. It's going to stay in the code. There's new requirements for duct leakage levels for any compliance path. There used to be just for specific compliance paths. So now you got a requirement for all compliance paths within the code. So it's treating them equivalent, whether you're doing prescriptive or whether you're doing performance. There's a maximum total duct leakage that has been changed to, and what that does is that supports the modeling. So when you're modeling, you can take credit elsewhere within the building. And testing, of course, is at rough or post-construction. In this slide, so heating and cooling, we're talking about ducts here. So supply and return ducts, what's happening here is it's more clarification to the trades on where the ducts can be located, where the insulation should be placed around the ducts. So you've got some examples here, a couple pictures on the left and the right. From the one on the left is from the top view of a wall, and you'll see if there's a duct there, it's on the house interior side. And then on the right, you've got ductwork in floor over garage. Now on the one on the left, you still have insulation requirements. On the left, you can see how they framed out to keep the insulation levels at a level that it meets code or definitely meets the model. On the right side, same thing. You're going to be framing down and having the amount of insulation needed for that building enclosure. Even though you have a duct there, you need to enclose that in equivalent insulation. So there has been additional requirements included to support the industries to get a building to operate efficiently, to get those, support the duct leakage, to support the insulation around those ducts. And so those are new requirements that have come in. So earlier we talked about super insulation. You might not see it if a building is constructed this way, but you're going to see frame outs under garages so you have enough insulation for that duct if there's ducts in that floor system. The next is water heat. The water heat has become more and more viewed as an area that needs to be addressed as the building enclosure has improved, as the air infiltration part of the building enclosure has improved. And so there's less air leakage, there's less heating and cooling demands on the building as the windows have improved. So there's less demands today in today's building codes and those loads than there was 20 years ago. But water heat has become a larger percentage of the loads in buildings. So water heat is often overlooked, but in some cases is often the largest energy expense compared to others. So it is important for designers and builders to select and locate the water heater or the water heating technology, along with other measures to minimize the hot water use. And so what's coming into one of the compliance paths, as many builders are using the performance pathway as a code compliance pathway, and this will come into that pathway, it's compactness of hot water systems. So think of your house, think of a house, think of the size of the house. Let's say it's a 5,000 square foot house. And then what this does is it looks at what is the area that is the water system, the water lines, your tanks, your faucets, and so forth. What area of that? Is it 1,000 square feet? Is it 20% of the overall building? Is it 100%? Because there's a bathroom on one end of that 5,000 square foot house, and there is a kitchen on the other end. And so there's all the plumbing and the system across that entire 5,000 square feet. So what this is doing is just looking at, okay, if you've got a smaller compact area where you've got your lines, hot water lines. So this is not taking into consideration cold water, but your hot water lines. So you've got your faucets and you've got your hot water heater and so forth. That becomes a factor for hot water distribution systems. And so the more compact, and if we think of homes 50, 60 years ago, 40, even 40 years ago, they were designed where you had bathrooms back to back. Many homes are still constructed that way, but they were stacked. So there was minimal plumbing requirements. And that's really what compactness of hot water systems is doing. It's looking at, is it reducing the area within the structure where you're going to have hot water lines running and all of the different parts of that system, faucets, tanks, and so forth. That's coming into the code. That was fully supported from the committee for the 2021 on through all of the different code hearings as a benefit. And also, I believe that with all the work that I've done, that it's definitely an economic savings for the home builder to centralize where they can hot water, their hot water system. The other piece that's coming in, as we talked about hot water being a large percentage, is this code, as I've seen in other local municipal codes, gives options. So you have options. You're not having a conflict with NECA because you have options. And in this case, this option, this is the first step into the energy code where it's talking about heat pump water heaters with a specific UEF, which is modified energy factor, and talking about tankless. This is only one of the pathways. So if a builder goes with the performance and the modeling, which we've talked about as the #1 item here to get to 0, then they wouldn't have to follow this. But if they went with the prescriptive path, and they went exactly with what the table said, R this and U that and so forth, then they would have to choose from one of these 6 hot water technologies within the home. And it's not preventing a builder or designer to look at any of this technology, but this is only applying prescriptively. I think we're going to see more of this move into the performance, where you'll have those options. And we talked about that in some of the early slides, where there were some options there for performance modeling. Okay, I think that was my first in this webinar. So we're now going to move to number 8. And this is one that, a topic that's coming up weekly. If you can go to our website, SWEEP's website, we released a report in late July on building electrification and some model code language, because we see municipalities in our Southwest states that are asking the question how they can move to carbon-free energy, how they can move to 100% renewables, and how they can meet some of their greenhouse gas goals, their climate goals. And so electrification is an area that is coming into the codes. It's coming at the local level, coming at the state level, and now here at the national level. This all supports the ability to use renewable energy on site or renewable energy off site. But it's really electrifying a building. Now, we have about 25% of our building stock across the country, according to the EIA, is all electric. They don't have any kind of fossil fuel, any kind of gas or propane. So they're already all electric. And so we know buildings can be constructed that way to operate with only electricity. And the codes allow that. There's not a limitation on heating or cooling equipment of which type you can use. But electrification is coming in to the codes. So again, you want to go to the SWEEP website. My information is at the back slide. You can take a look at our recent code on showing case studies for electrification, and then some model code language. And then weekly, there's a new report, new study coming out on electrification with buildings. And I just saw another one today with an organization we work with here in Colorado, where I'm based, Group 14, looked at electrification of buildings. And so on and on, electrification has been in the forefront of discussions with buildings since the beginning of this year, and I believe it will continue through into the next few years as communities are looking at greenhouse gas goals, climate goals, And the IECC, excuse me, the ICC, International Code Council, has a number of subcommittees of their Sustainability Membership Council that are addressing areas where ICC can support their members and support the codes. They can't design a code, that's governmental members that design the code, but they're looking at ways for grid interactive buildings, for zero carbon, zero energy, and what the ICC can do to support industry. And this is because of electrification. So next slide here. This is what's happening in the proposed 2021 IECC, and this is what's happening at the local level today. Again, I'm not pushing my report, but take a look at our report and you'll see some case studies of municipalities that have already implemented requirements like this. So in this case, this is, we're calling it electrification ready. And this is so if you're building a house and you've got a gas dryer, you need to also have an electric outlet there. If you're building a gas range, you also need to have an electric outlet there. And then same thing with your water heat. And so this is making that building ready to use renewables. It's ready to move to zero carbon. And that all depends on what the electrical grid is. But if they're using renewables locally or renewables on site, then they are consuming electricity that's zero carbon. So what this does is it makes a building electric ready for these components. Now, we don't have to worry about the air conditioning system because you already have the panel capacity, you already have the space, you already have the outlet there. You don't have to worry about the heating equipment. You already have all of the circuit there ready to support the heating system or the AC, the cooling system. But in this case, you might not have it there for gas range or a gas dryer, and definitely a water heater. So this is putting this electrification ready requirements in residential, and so it's providing space in the electrical panel, and it's defining a type of circuit breaker and labeling. And what's happening here for the water heater space is this is only a requirement if you're not building, if you're not including a heat pump water heater in the building when it's being constructed. So if you do, you don't have to comply with this, but if you don't, then you have to have at least this minimum space around the tank for the needs of a future heat pump water heater. Now, with that said, I just saw a recent product that was sent to me called a Senko heat pump water heater. And that system has an outdoor unit. So it's not an integrated one tank system. It has the outdoor unit. That's where the water is heated and then it flows into the tank within the building. And so that would not need this level of space. But for this code proposal, electrification ready, you need to leave some level of space if you're using a typical heat pump water heater. And we're starting to see other electrification pieces. I didn't go into it here, not really part of zero energy codes or zero energy buildings, and that is EVs, electric vehicles. They're coming into the code too. We're seeing it at the local level, we're seeing it at state level, that there has to be some level of EV readiness. Could be similar to what we're talking about here. Others could be just the conduit and open space on the panel. but others are EV capable, EV ready, and so there's differences whether you've got the wire running, whether you don't have the wire running, but that is happening as the vehicle industry is seeing a growth in electric vehicles. Right now, it doesn't seem like many, but all the major manufacturers, Ford, Chevrolet, Toyota, and on, are saying they're going to have X number of vehicles electrified in the next few years. And so we anticipate seeing more and more electric vehicles, and the easiest place for them to charge is at night at their residence. And so the code, and I'm not showing you any slides here, the code does address for multifamily and commercial buildings. So the code is looking at all types of buildings and all types of residences to support that. This right here, this is residential that we're talking about here. We're not talking about commercial. Okay, and I'm keep moving so I can stay on schedule so we can answer any Q&A. So number 9 is lighting. That's an important one. This one, we've really hit a lot of that with the LED technology. And that continues to improve. So in the code here, the lumens per watt are coming down than what was required. Technology's there, products are there. The other thing that's coming into the code that we see in the commercial code, but not so much in the residential code, is permanently installed fixtures need to have some level of a control. So not just an on and off switch, yes, that's a control, but a dimmer or an occupancy sensor or some other kind of control installed into that fixture. That is permanently installed only. So you can think about permanently installed, where they are in a house. And then here's your exceptions. The first one you might think of is a bathroom. Well, that's an exception. Might be a hallway. That's the other one that comes to mind. That's an exception. So for single family, exterior lighting fixtures are an exception where you don't need to have a control, or anything that's designed for safety or security is also an exception. Where there's new requirements are coming in, and this supports getting the attached units, multifamily, to a lower energy consumption level, is commercial multifamily, 4 stories or greater. There's lighting control requirements, interior and exterior. And those interior go beyond what we were just talking about for residential. But there are exterior lighting requirements now. And this really fits that multifamily market, 3 stories or less, which was residential. And it didn't have these requirements, but now there are requirements for those commercial multifamily developments. In many cases, the multifamily developers have already been installing controls and meeting the criteria of the commercial energy code requirements for exterior and other hallways and stairwells and so forth. So the exceptions here: 1 and 2 family dwelling units, lighting that's already complies with high efficacy requirements, solar powered lights, and anything motion sensor that we were just talking about earlier. So really, where this is going to help the multifamily units, it'll be 3 stories or less multifamily to move forward. Okay, now we are at renewable energy. So we've hit performance modeling. That's the way to get a residential building to 0, because then you can look at all of that building and you're able to trade things off, you're able to tweak areas of a wall assembly or a floor assembly. And so performance modeling really is the way to get to zero. And then tight. We want it to be tight, that building enclosure. We want insulation, good levels of insulation. So there's that comfort level, both in cooling climates and in heating climates, and continue to improve the windows and doors, mechanical ventilation, heating and cooling, where it can be improved, but definitely the ductwork, water heat, we talked about that, electrification ready, that is coming into the codes, and then we just talked about lighting real quickly. Now we're going to go to renewable energy. That's the next piece. So to get to zero, there has to be some level of renewable energy. The areas that are being discussed in the codes today are on-site, off-site. Those are some areas. And one area that's being, well, this is a proposal into the code, the 2021 code, is renewable energy certificates. And this, my take on this is most consumers don't care about this. They might, but they really want to know, does their solar system or does any other renewable system, wind, does it perform? How long does it perform? How much does it produce? How much is it going to save them? But there's something behind that called the renewable energy certificates. And this is where utilities can take credit for renewable energy certificates. They can get to renewable energy certificates from out of state, where some of their energy may be coming from. But for residential, renewable energy certificates don't often go with the system, the solar systems, and let's just stay with solar systems. Those panels sit on the roof, and yet those systems could be owned by third parties. And in this case, some documentation is showing that 70% of the solar systems are owned by third parties. That REC then is sold to some entity. Could be a utility that needs to get to a certain level of renewable energy. And so documentation of the REC and who owns it is addressed in the code. I've had some issues with that, and I was on the recent IECC Residential Energy Code Committee for the 2021 code. And RECs are great. I just don't know if it's where it fits. So does it fit in the code? Does it fit in some zoning requirements? This is one that there's a model code that goes across the country, adopted at the local level, adopted at the state level, versus planning and zoning codes typically developed at the local level. And so this is a place where it felt that it fits. And so it'll be interesting to see how the industry adapts and works with this if a building department just says, okay, this is great, we're going to pass this responsibility off to a different department. We'll see how that comes out. The other piece about solar ready is, solar ready. Renewable energy is solar ready, and that's been in the code for a couple cycles. And that is in the residential appendix. It's also in the commercial appendix, and that's defining what level of area on the roof is available for solar. What is the panel capacity? Where is the ability to chase a conduit to move from a roof to the panel, and reserving space in the panel and labeling. That all gets the home ready. Not quite what where the zero energy ready home requirements are. They have those requirements. They also have an area near the panel that has to be reserved for the solar system, but the energy code doesn't yet include that. Will it be there? I think it will. The solar ready appendix, these are appendix, they're starting to be adopted now. Since it's been a couple code cycles, we're seeing more and more municipalities say, we're going to adopt it. We're seeing a large number of solar systems going in. So, and it's not requiring that you have to put panels on, but it's getting the building ready through documentation. So then when the solar system comes in, here is available roof space, here's available chase area, conduit area. And so that's another piece of renewable energy that's in the code to drive it to zero. And then the next one is zero energy. And I live in the Denver, Colorado market area. And Denver has stated, and they've put a plan in place, that by 2035, all their new buildings will be built zero energy. And they'll be electrified. They're working on that, on the building electrification piece along with that. And so they're going to step in over numerous code cycles to get there. And so, but today's code is there. California, of course, has been there, but other states are looking at ways to how they can get there, and municipalities are how they can get there. Some want to move quicker. They have some urgency. Others are saying we're going to stay with those 2030s and 2050 dates that are out there. So I know I'm at the top of the hour, and I want to, I'm close to finishing up, Mike, and all of those that are participating. So zero energy, right now in the energy code, it will be appearing in the appendix. So when you get the 2021 code, they'll appear in the appendix, and there'll be a couple. They're developed in a national process. And so that makes it easier to implement locally. As I just was mentioning, municipalities want to move to a zero, want to move to a zero carbon, zero energy. And having a product developed nationally, vetted nationally, that's now in an appendix, that's great. Then municipalities can take it and they can tweak it. They can amend it. They can make it, they can move quicker. They can move in phase step pattern to get to their goal. They've got those goals of zero. So in the 2021 code, you will see a zero energy appendix for residential. You'll also see something for commercial, but for residential, which is what we're talking about today, this zero energy appendix, fairly simple. And this is where a municipality could take it and phase it in. And it's saying, okay, here's your ERI. So think of that 50 mile per gallon or HERS score. It's the same. The score is the same. Getting there is a little different. But here's your scores, low 40s to mid to upper 40s, 47s. And that's what you have to get that house to, the ERI, with all the ERI requirements, without on-site power. So you get that the house there, then you're ready to go to zero. Then you need to include on-site power to reach that zero. That's what this appendix says. And so municipalities could, again, tweak that, could say you're going to meet this middle column, you're going to meet this ERIs in the 40s, and then you're going to step down over every 3 years, you're going to step down X, whatever that X is, 3, 6, 10 points to get to that zero. So flexible, there would have to be some options made, amendments made to this, but it really positions the code to get to zero and supports municipalities where they don't have to develop an extensive pathway, and knowing that this was developed nationally, vetted nationally. So the groups, the stakeholders that came together and worked on this to include this in the appendix were national. They looked at the HERS scores nationwide, looked at the HERS database. They surveyed the HERS scores. They looked at ASHRAE 90.2, which is the efficiency standard for residential. They looked at what they had come up with and all of their analysis. And those numbers that we just saw, those align with 90.2, the ASHRAE standard, before you get before zero. So that was the middle column. Looked at the US DOE Zero Energy Ready Home program. And then the other key point is the house needs to be buildable. It can't be something that is totally off the wall and is not current building practices, and would be unbuildable. So it needs to be buildable. So really the house is going to look relatively the same as a code-built home today. You would have solar, of course, but there would be things that would be happening on the inside with super insulation and windows and doors and those other things that we've talked about today that are in the code. And then the residential zero energy proposal that I was just talking about, it's linked to the ResNet standard. So the score is a score. And so no game playing, and the game playing pieces that kind of can happen at either the national or the local level where they start tweaking some things. Well, in this case, it's standard ResNet standard IECC standard 301. And it's much more challenging to tweak that standard than it is the energy code. And then it also includes the ability for on-site and off-site. And so this is, as we've thought about zero energy before, we've always thought of solar panels on the roof, and they're going to offset the energy consumption for that building over an annual basis. And so, but there are some buildings that residential developments, it could be located in an area where they have minimal solar exposure. They could be near a mountain. They could be near a forest. They could be near homes right off a downtown area. And so off-site power is included in this. And so it's an adjustment to the on-site power. Is anybody using this right now? None that I'm aware of, but there will be some that will be moving into this area. So that's zero energy. So I talked about performance modeling. That's the way to get there. Tight buildings. The building code is going there and it's flexible. Insulation, super insulation. Depends on what you think of as super insulation, but the code is moving, has moved there with insulation values. Windows and doors, lining up with Energy Star. Mechanical ventilation is important. Heating and cooling systems to some level, but definitely the duct systems where they're located. Water heating, what's happening with water heat? Electrification, pre-wiring, electrification, that's a big one. That's an area that's coming. Lighting, some improvements in lighting, renewable energy, and zero energy, and how we're going to get there. So I believe the code's on its way. I believe you could take the code today and build the code, the 2021 code, let me phrase that, and build that, and you've got a zero energy home. And then you're going to, of course, add renewable energy to that home or some other type of renewable energy. So that's where I'm at. I want to thank you for the time. Thanks, Mike. Again, if you want to see the report that we just wrote, go to that domain, swnenergy.org, look at the latest report that we wrote on building electrification. And there's model code language for residential and commercial, different levels of electrification in a building, such as the pre-wire that we talked about coming in the 2021 code. So thanks for your time. The energy code is going there. A lot of work, appreciate a lot from the DOE and Zero Energy Ready Home program and the DOE program, the Building Energy Codes program. A lot of information that they provided and education and support they've provided to the industry as these codes have moved forward to the level where you see them today. So thanks so much for your time, everyone.
All right, thank you, Jim. And we have a lot of questions. Please send in your questions via the questions box. We are going to make sure to get to all the questions. So if you have sent one in, you are going to get your question asked. So we're going to go ahead and start with a question, kind of not necessarily go in reverse order, but I'll try and categorize some of these various questions. So Scott had a question about the computer simulations that you talked about early in your presentation. What is the margin of error on those? Like how precise are those?
That's a question that's been asked for many times. So ResNet, which is the predominant tool that's used for, or at least the standard that's used for modeling, is I don't have that off the top of my head, but you can go to the ResNet website and look at their standards. They've done a lot to make sure that there's consistencies between the software, and so they align up whether it's a large home, a small home, the climate zones, all of these pieces. And so the energy code is relying upon that standard. It's an ANSI approved standard to have some level of equivalency. And so I'm going to have to push it back to you. Take a run over to the ResNet website and see what they say is the difference and the deviation between the acceptable deviation in their software requirements.
All right. Oh, and just to let our audience know, there is going to be a email sent out after the webinar, and you'll be able to get the slides or get the presentation through that. That's right, Jim? That's
yes, correct. Mary will do that. Yep.
Yep. All right, great. So I want to move on to insulation, some insulation questions if I can. We had a question about, from Scott again, it was asking about insulation amounts. Do those take into consideration thermal bridging, or is it just looking at the thickness on the wall?
Right, so yes, they take into consideration thermal bridging. So each of those, and I just showed the R value, it's easier to look at the R value. It's easier for all of us to picture an R30 versus an R19 or an R13. So that's what I showed, but there are tables within the code that are the U value tables, and all the modeling software uses the U value tables, and so it does consider the framing factors within those U values.
Okay. You know, I had a question for you, Jim. When do we get to the point, because I mean, you've said on these committees you've gone and testified, I've gone and testified too. When do we get to the point where, the point of diminishing returns when it comes to insulation?
Right, that's a good question. and as Mike knows, I used to work in the insulation industry years ago. And so I think when you look at a passive house and the level of insulation, passive house, you can see where it's cost effective. You've got that big bridge you have to jump. But once you make that big bridge, then there's massive amounts of energy savings at the passive house level. And so, yes, some components, you will have that diminishing return. So Example, I sat on the committee as Mike was talking about, there were improvements or there were increases in energy efficiency in climate zone 2. That's Phoenix, Tucson area that that's part of my territory. And I didn't support the insulation values in the attic because I thought we could have driven even further down with windows. We could have driven the SHGC down in windows and the VT, visible transmittance, up. It's already, the technology's already there in the window industry. But there wasn't a proposal for the windows. And so there will be some areas where we're hitting diminishing returns today, I think. In other cases, we still have ways to go.
All right. Well, thank you for that, Jim. I want to move into questions on ventilation and a little bit on leakage too. So we had a question from Stephen, and I think this is kind of a good starting off point. Can you explain to the audience the difference between HRV and ERV, and when would you use one over the other?
Okay, the ERV is the energy recovery. And so think about where you've got a latent load, where you have humidity, and you have to take that into consideration. This is the easiest way that I've always thought of that, because out here in the West, we don't see ERVs. We're in a dry, arid climate from Colorado to the West. And so we see HRVs. You're just having that heat recovery. But the ERV is also taking into consideration that the latent load, that humidity piece. So look at one of the, look at the map in the energy code and see where those lines are for dry and moist climates. And so where you're in moist climates, think ERV. Where you're in arid climates, think HRV. Not that an HRV can't work, or an ERV can't work in an arid climate, but you really would want to have that ability to support that latent load in those moist climates, and that's where the ERV comes in.
So you talked a little bit about moisture, and I want to get to this next question here. It's from Donald. He wanted to know, or he states, many builders say, and we go to those hearings, Jim, we hear it at the testimony. Many builders are saying, oh, the homes are getting too tight, and we're causing moisture problems. So Donald wants to know, how do you respond to that?
How do I respond to that? Sure. If we build to the codes, and that's where I showed that table. There was the air barrier and there was the insulation. And I said, think of it as a checklist. It's not a checklist, but think of it as a checklist. So there are many in the industry. So raters I've visited with and talked to. There's energy code consultants and trainers. And there are the insulation industry. If we build homes and we meet all of what's in that table, air barrier and insulation table, then we're going to have less and less possibilities of those moisture issues that you're talking about. I'm not saying you won't have any, because who knows what people are going to do when they move into a house and start operating the house and adding to the house. But overall, you've got your air barriers, you've got your vapor retarders. That's in the construction code, the IRC. You have ventilation. You have all of those pieces in there. And if it's all built to the code, we minimize that issue. If we're not building to the code, and we are definitely adding moisture after an occupant moves into the home, then that's a different question. But even when an occupant moves in, the house is designed to support those occupant loads with everything we talked about today, from tight mechanical ventilation, insulation, on and on.
so then that leads me into a question from Mike. He wanted to know, why still allow exhaust-only ventilation in climate zones 1 through 6? Positive or balanced or at least hybrid approaches are all viable options, according to Mike, in which the fresh air comes from a known location.
Yep. So yes, Mike, from a known location is key. You're right. And I'm going to have to just say it's the process. Politics, different organizations that participate. So you have your governmental members there. You have product manufacturers that are part of the development process. You have builders, you have trades there participating in the development of the code. And why it's not there? It's not there because I think that the first step, as I mentioned in climate zones 7 and 8, we've made the first step to include ERVs and HRVs. I think in the next code cycles, we will start to see that requirement come into climate zones of lower climate zones, 1 through 6.
Okay, so I'll look for that in the 2024 IECC.
Yeah, I mean, again, I believe it'll be stepped in. I'm not. It would be great if it could go in across the board, but I believe it's going to be stepped in. And definitely at the local level, there we might be seeing some municipalities saying, "Well, this is good." Like Mike was just saying, it's good for climate zone 7. Why can't we do it in climate zone 5? Especially if it helps us get to 0.
Right. Well, and so then Donald's asking about the testing of HRVs and ERVs. He says it can be challenging on some homes. Is there any way the code can require a test port on the unit so that they can be tested indoors?
I don't know the answer to that, Donald. I don't know if I would see it in the code, because the code is not specifying any kind of any specificity to a certain type of component, like a window. It just says, here's your U value, here's your solar heat gain. And it's saying, here's your insulation. It's not saying what kind. It could be a mineral, a fibrous product. It could be a foam product, a poly product of some kind. And so I don't see that. Where I see that happening is industry coming together and the trade association that represents that industry coming through and saying, this is a value. We need to include this. And then they can't mandate that the product manufacturers add that, but they could put it within their best practices. Yeah, from a code, I'm not sure whether I see that coming into the code.
Okay. Another question came in from Mike. He says that, in his opinion, the great part of using CFM 50 per square foot of enclosure is that a single spec can be written and applied to virtually any size building. So why not apply this to single-family detached as well? He feels that it would eliminate the bias that large houses gain from the ACH 50.
Good question, Mike. Were you at the code hearings? You should have been at the code hearings. Yes, there were people at the code hearings over the last few cycles saying the same information that Mike has just brought up. And will we get there? We may. And the way that we can get there is to have more Mikes participating in the process, communicating about code changes, proposals, speaking about them at the hearings to make this shift. So I believe that I mentioned when we were on that slide that this was the first step. Do they align? No, they don't align when we went to 0.30 CFM per square foot and the ACH, but it's, again, a step in there, and it supports those smaller buildings. One of the things that the Energy Code doesn't reflect either, Energy Stars or Energy Ready Home does, is the size. So there's not really a size or an adjustment factor for that. That a 1,000, 1,200 square foot house is going to use much less energy built to the same code than a 5,500 square foot house. So that's not in the code, but municipalities are going that way. We have 2 in Colorado, if not 3, that are there, that say you build a 5,000 square foot house, you have to do X. You have less requirements if you build a 1,500 square feet or smaller house.
Well, and the Mike who's asking all these wonderful questions is not me. It's Mike with Southface, which is a wonderful organization out of Atlanta. And so, yes,
Mike,
I will second that motion that he should go to the code hearings.
You need to come to the code hearings, Mike.
That's right. All right, moving on to, let's talk a little bit about duct testing. So Peter had a question, because you had a slide about heating and cooling that stated that duct testing is required for ducts in conditioned space. He wanted to know, is that correct? He's always thought that duct testing is more important when the ducts are in unconditioned space.
Right, that's a good question. Lots of discussions again. These discussions are happening at the local level too. And so the questions are the duct tests, total leakage or testing to outdoors. Those continue to come up in with the Energy Code. The focus here was what was the loss of energy for ducts that were not located in directly conditioned space. So you can have a semi-conditioned attic, and that's considered conditioned in the Energy Code, but that conditioned air is not moving in, any of that leakage is not moving into directly conditioned space. Same thing with anything running in a floor, anything running in an interior wall. And so this has been discussed, oh gosh, maybe 10 years now for the codes. And so this was the first time that this was approved by the online governmental voting members, that duct testing was required for all ducts, even those outside a conditioned space. So I don't know if I have an answer for you, other than has been the discussion over the years of having that conditioned air moving into directly conditioned space and not indirectly conditioned space or semi-conditioned space.
Okay. Let's talk about water for just a little bit, Jim. Got a couple questions on water. One was from Rob. He wanted to know, there's this additional efficiency portion with the heat pump water heater option with a UEF of 2.0, and it's also in the additional hot water efficiency. So can you use one technology to serve 2 purposes?
Good question. You cannot.
Okay.
You cannot. So in that additional efficiency options, which is commonly referred to by the proponent as flexibility, flexible options, flexible points. And so this is, they cannot be double counted. That's just the easiest way to say. Yep, it has to be a different efficiency option they choose. Now again, that the water heat is only if you're building your house prescriptively. So if you're modeling and using that pathway, then you don't have to you can, but you don't have to use any of those water heating systems. And so then you could use pull and count that for your efficiency option for the performance path, ERI or performance.
Well, Laura had a question. She wanted to know, what about drain water heat recovery as a water heat efficiency option?
Oh, wow, now you're racking my brain. Do I need to open my code book and see if I think we've got drain water in the code today. I'd have to search. If you send me an email, I will let you know. There's my email on the last slide. But drain water has been discussed, and my brain is a little fried right now. But we got heat trace, we've got demand recirc, hot water pipe, drain water heat recovery. There we are. So it is drain water heat recovery unit shall comply with drain. Yes, that's what I thought. So it came into the code back in 2015. No, came into the code in, yes, 2015.
Okay. Cool. So it's been there for a couple cycles now.
Yeah.
So there you go, Laura. So we're going to move off of water for a minute. And Jim, we're going to say aloha to our friend Howard.
Hey, Howard.
Yeah. And he had a question. He said, well, look, standard lamps are now exceeding 100 lumens per watt. What about exempting dimming and occupancy requirements when the lumens per watts exceeds 85?
Yeah.
Can we do that? These ones?
Sure. I mean, yeah, that could be done at any level. I mean, at a municipal level or state level. I know there's been discussions that are controls as important today because, as Howard's mentioning, the efficiency of the lighting. So those lamps are getting really efficient. And so do you really need to look at controls? And I think, Howard, this might be one area where the controls are amended at the local or the state level because of more efficient lamp efficiency issues you just mentioned.
I wanted to get to a couple other questions and then send out the final call to send in your questions. We had a question from Mohammed. He wanted to know, where do you get more information, whether it's websites or it's documents or even just names of different programs when it comes to performance modeling?
Where do I get more information about performance modeling?
Is there a place that's got some good resources on performance modeling? Is there something through, I don't know, Building Technologies Office of DOE or?
So you can, well, ResNet it would be the first place I would go. Take a look at that. They have standards that they're following that they're developing, that the software industry is following. That's what I meant to say. And so you have that. NREL, National Renewable Energy Laboratory, has done a lot with modeling. They've developed software, so they've got Energy Plus, BOPT, number of tools they've developed that have moved out into the industry. And so they have information about that. The Building Science Solutions Center, DOE, maybe it's just the Building Solutions Center. Check that out, Department of Energy, do a Google search on that. They have information. I wouldn't say ICC, I wouldn't go to ICC for any thing because ICC is referencing standards, so it would take you back to ResNet for the ERI. But those would be the few. The other one I would go to would be ASHRAE. And I'm drawing a blank right now on the number, what standard that is for modeling. But I would go to ASHRAE, look to see what standard they have for modeling software. That would be more appropriate for commercial buildings than residential, but that would be a good standard to look at. Unfortunately, finding a free view of that might be a challenge. They provide free view for some of the more popular standards. And I bought some non-popular standards, which are great to have, but they've typically over $100 a standard. So that's where I'd start, Mohammed.
And I guess I'll ask you kind of a follow-up to that as we go through the alphabet soup of organizations. You mentioned ASHRAE, and it made me think, is AHRI going to have anything in that regard, or the other organization I was thinking of was NATE, N-A-T-E?
Yeah, I wouldn't think NATE does. The other piece for modeling would be the ACCA, well, the ACCA.
Oh, yes. Yeah.
So I call it ACCA. I know if there's anybody from ACCA, I apologize. It's ACCA. So they have the standards. So you could go look at their standards. So they've got they're on version 8 of their requirements for loads. So they've got their standards for equipment, got their standards for ducts, and then they've got their standards for loads. And so that's the other one. And I should have put that into the mix at the very beginning. And so those software that comply with under ACCA Manual J version 8, they are also a modeling tool.
Okay. And we're going to get bailed out by your colleague, Christine here, Jim. So this is going to further my theory that there is an association for everything. There is an organization called the International Building Performance Simulation Association, and they have a regional affiliate in the United States. So yeah, there is the IBPSA, International Building Performance Simulation Association.
Yeah, thank you, Christine. Yes, they are mostly commercial focused, but a good place to go. Yep.
And then BPI wouldn't have anything, would they? I mean, I know they're more for existing buildings, but
yeah, I don't know.
Okay.
I apologize. I don't know that.
Okay, that's fine. All right, so I got 2 more questions. The first one I'm going to get to is from Jerry, and the question is, and this is interesting, Jim, because I don't know if, especially since you've been on the committee, I'm curious when I ask you this question, if this is something that would fall within the scope of the IECC or the IGCC. The question is, will high global warming potential insulation materials be eliminated by code in the near future? Some have a GWP of 1400, but there are generation 4 materials that are near 0 GWP.
Yeah, so that would, from the code industry, looking at ICC, that would definitely fall under the IGCC, which is really going to ASHRAE 189, because IGCC, the administrative chapters at the beginning of that code are developed by ICC. The technical chapters are now ASHRAE 189. And so I think that would fit in ASHRAE 189 versus an energy code. Now, with that said, I've seen a lot of things included in codes locally. And so Could that be included locally? Could be. I don't see it happening at the national level. I see that playing with SRE 189,
okay,
which is a green building performance standard.
Yeah. Well, and the final question that I've got here is one from me, and just because we have a good relationship, Jim, I'm going to open up a can of worms that you didn't touch on. I wasn't going to let you avoid this.
I talked about EVs.
Plug loads.
Oh, yes. Yep.
How do you even start to regulate that? Or do we not even go down that road?
You know, the commercial code, commercial energy code, has started down that road. And it's outcome-based codes. So you might have heard that, but you can take a look. One organization that's done a lot of work on that has been New Buildings Institute, NBI, newbuildings.org, outcome-based codes. And so run over to their website and take a look at what they have. The challenge there is, yes, we don't know plug loads. How do you unless you get a picture in the future of the energy consumption, you won't know how the plug loads are impacting the use of that house. And then, of course, you could have a house where 2 people live in it, and you can have a house where it's a large family and they've got 4 kids. And so the energy usage will definitely look different. So I'm one that, this is me, only me, that I think we design the building operate the best as it can, reflecting that the more bedrooms, there'll be more occupants, okay, and support that. But we don't know what's going to happen with plug loads. We don't know how many they're going to put a TV in every room. If everyone's going to have 3 mobile devices always plugged in, and laptops and on, and then let alone what's happening today, how many of us are working from home and not in an office? And so that's impacting energy consumption in the building. In fact, I saw an article the other day about that. It might have been in Forbes or New York Times, one of those. Anyway, talking about energy consumption in homes has changed because people are working from home. It just makes sense. They're working from home. They're not consuming energy in their office building. So well, I'm one that I don't want to go down that road. Others have. So check out outcome base codes at newbuildings.org, and I know Seattle has gone down that path. They started down that path 4 or 5 years ago. I haven't had a conversation with them over the last couple of years, but I know that it was struggle. There were some struggles with that, how they could get a code to comply in the future.
Yeah. Well, and, you know, look, I'm the one who asked the question, but I'm going to push back on my own question because the enforceability of it, I just don't know how that happens once the CO is issued.
Yeah.
That becomes hard, and not just even looking at the future as far as change of ownership of the house.
Right.
It's also just even the topic of plug loads. I mean, I think some of my devices have devices somehow, and it's like this stuff just keeps spawning itself, and you're just like, man, this stuff plugs in a lot, and I think it just becomes pretty difficult to do. And if you look at even like the ERI path, just look at ERIs in general. They are basically asset assessments. They're not really taking occupation into account. I mean, they kind of take an occupation into account by counting number of bedrooms.
You do,
but
right.
But you're making the assumption that roughly these many people will live in this house.
Correct.
it can certainly fluctuate to an empty nester of 2 versus a full family of 4, 5, 6, 7 people. And
Right.
that's quite a variance in electrical usage. It's a variance in water usage.
Yep.
So
Yep.
if you look at what's in there now, it's really looking at, hey, what's the general idea here, as opposed to, well, I have to know exactly how many people are in this building at all times.
So one area, and we can close with this, one area that is addressing this, and that's the appliance standards. So if you think we've got appliance standards for equipment, heating and cooling, there's appliance standards for all kinds of appliances out there. And then we've got lighting appliances, lighting requirements. And so the appliance standards are a way to support that, the plug loads by continuing to improve those, and I say appliances, but it's a whole mix of electronic products, improving the efficiency or the energy needs for those products to bring those plug loads down. So look at TVs, look at refrigerators and dishwashers and and freezers. They've come down. So the appliance standards are supporting these energy codes, and that's where plug loads are one way to support the plug load question.
All right. Well, it's a good one to stop on, because I don't see any other questions. So I want to thank Jim for coming on back again, sharing his time and his knowledge with us. We really do appreciate you having the chance to join us again, Jim.
Thanks so much, Mike. Thanks everybody for participating. And Mary will be sending along my my slides.
And thank you to that audience we had today. It was awesome. They had great questions as always. And thank you to Goodman Manufacturing, Train, DOE, Team Zero, and EBA for their generous sponsorship of this webinar series. You are going to be back next week for the 4th DOE webinar in this 5-part series. On Thursday, September 3rd at 2 p.m. Eastern Time, we're going to visit with Steve Easley as he shares some net zero success strategies. Won't you join us then? That's all we have for this week. Until next time, stay safe, stay healthy, and so long for just a while.